Diffraction of waves. By the end of this lesson, you should be able to describe diffraction of waves in terms of wavelength, frequency, speed, direction of propagation, and shape of waves. Draw a diagram to show diffraction of waves. Have you ever seen boats by the harbor with sea waves beating on them and creating patterns of waves around the boats? Observe what happens to the patterns of waves as they pass the edges of the boats. Why does this happen? As the water waves reach the edge of the boat, the direction of the waves changes as if they are spreading out. The shape of the waves also changes. Describe the pattern of the waves after passing through the gaps of different sizes.
Click on the pictures to start the wave motion.
When the gap size is approximately equal to the wavelength, the wave pattern after passing through the gap is circular. When the gap size is bigger than the wavelength, the wave pattern after passing through the gap is less circular. The wave fronts are bent at the edge of the gap. Wave fronts far from the edges of the gap will pass through without bending. What can you say about the wavelength of the waves after passing through the gap?
The wavelengths remain the same.
What can you say about the direction of the waves after passing through the gap? The waves bend and change direction near the edges of the gap. This is called diffraction. Observe the waves when they meet a barrier. What happens if the length of the barrier is larger than the wavelength? The waves bend around the edges and fill up the space behind the barrier. A shadow area is formed behind the barrier. When the size of the barrier is smaller or approximately the size of the wavelength, the diffraction pattern of the waves is more obvious. When the size of the barrier is larger, the shadow area is larger. The diffraction pattern of the waves is less obvious. Have you noticed that you can hear the sounds of the radio from another room? Sound waves can be diffracted around corners and through doorways. How is this possible? Sound has a much longer wavelength than light, so sound can be diffracted easily around buildings or through doorways. This is why you can often hear people, although you cannot see them. Sound waves are diffracted as they leave their source, for example, the radio. When the sound waves meet walls and doorways, they bend around these barriers. Diffraction depends on the wavelength of the sound waves and the size of the gap or barrier which the waves meet. A laser source, a single narrow slit, and a screen is set up to observe the single slit diffraction pattern. What happens to the light as it passes through the single slit? Click on the laser to start the demonstration. A diffraction pattern is formed on the screen. Bright and dark lines or fringes are seen on the screen. The activity is repeated with a pinhole camera instead of the single narrow slit. What happens to the light as it passes through the pinhole? Circular bright and dark fringes are seen on the screen. This pattern shows diffraction of light around the edge of the pinhole. What do these demonstrations show? The demonstrations show that light can be diffracted. However, the diffraction pattern is not easily seen. This is because the wavelength of light is much smaller compared to the size of the pinhole. Drag a barrier into the tank and observe the diffraction patterns.